No.
For start.
Oh, you started? Oh. Hi, guys.
She said go.
Hi guys. So we're gonna do FRQ1. Sorry. We're gonna do FRQ1 model H, right? So on this one, the reason I want to do this one is because now instead of a table, they give you a graph, right? So let's look at A1. For A1 says find the function H, right, which is given by h of x equals g f of x, right? So this is your composition of functions. So here, you need to focus on the input they give you for h. So the input, because it's inside parentheses, is -1. So wherever I have x, because x is an input, right, you're going to put -1, -1. So now we don't really need h no more, right? It was only helpful to give us our input. So now we're going to go from right to left without jumping any hurdles. So -1 with function f. Function f is the graph. So -1 is right here. Where's my graph? Is it above it or below it? It's, well, below it, right? And then go to your y-axis and get your output. In this case, it's -2. So now I have g -2. So from here, g is this, right? This right here. So what we have to do is go to decimals and just graph it, right? So when we go over there, here it is, right? Take your equation, and once you do that, let me erase this so it won't look so hideous. Now that I have this, our job is literally to just put g and place a -2. So your answer should be 5.269, right? Now that I have that, what's next? Let's see. Let me scroll down a bit. So now it's saying find all the values of inverse function f with an input of 1, right? So the way I like to think about this is I like to make a table, right? X and your y. And my number that I'm focusing on is 1. So I have a 1 here, and then I have another 1 over here. So I'm gonna get my point. So it's 1, 0, and then I have 2, 1, right? So to take the inverse, all you're gonna do is switch x and y. So x and y, these flip. So now 0, 1, and then now you have 1, 2. So our input when you have an inverse has to be 1. So which of these two has it? This bottom point. So you're going to have your answer to be, for A2 to be F inverse 1 is going to give you an output of 2. So that's it for part A. For part B, it's telling you find all the real zeros of G, right? Find all the real zeros of G. So you have to use the equation. Let me erase this. You have to use the equation given by g of x here, right? The one that we graphed earlier. So find all the real zeros of g. So if we go back to decimals, you're looking for your zeros. Your zeros is when this green graph or any color graph touches the x-axis. So here it is. X should be equal to 2.133, or you can write the point like this in this format, right? Either or. So that was an easy one. What about B2? What is B2 asking for? Determine the end behavior of g of x as x is decreasing without bound. So going back over here, I'm gonna have for B2, I'm gonna have my limit. X approaches -infinity, right? So what's happening to g of x? So for starters, just by looking at it, it's constant. There's an asymptote somewhere in here. So I'm gonna keep scrolling. Look at the y. The y is not changing at all. The y is labeled as 5.4. So g of x, instead of going to positive infinity, because of that asymptote, it's gonna approach 5.4. Ta-da! Alright, so no camera pictures, no pictures right now, okay? Relax. Autographs later. So what else am I missing? Oh, I'm missing part C. Let's do part C. Ready? What is part C asking for? Huh. Determine if f has an inverse. Does f have an inverse? We have to apply the horizontal line test, so especially with graphs. Boom, anywhere, as long as this line is horizontal. Your goal with this test is to have this horizontal line touch the graph one time. And clearly for all these, it works and it happens, right? So does function f have an inverse? Yes, it does. So for C1, my answer would be yes. Function f has an inverse. Has and let me rewrite that. An inverse.
Trying to write hand.
I know. So now, why? Why does this happen? So the basic reason is each input has a unique output. That's literally it, plain and simple. Each input has a unique output, I guess you could say, for function f, right? Plain and simple, right? Basically, doesn't repeat, right? And again, if you want to keep adding to it, it passes the horizontal line test. You could also say it's 1-to-1. And that is literally it. Ta-da! Thank you.